So, back to this. So 5-1, solving complex. Now, complex makes it sound really hard, right? It's not. So complex means it's imaginary. So complex and imaginary are very similar. So last chapter, if we took the square root, or let's say we solved by the squared method, we couldn't take the square root of a negative number because everything squared is positive. Well, now we can. So this would happen in real life. Like, let's say I'm launching this rocket ship and it explodes right there. So it never has a chance to hit the ground and get a 0. So this is what is called an imaginary 0. So that's sort of a little bit of engineering in there where we use it. So I is the square root of -1. Right? So now that yesterday we talked a lot about this, that any number squared is right back to what you get underneath there. Okay? So that means I squared is -1. So I is the square root of -1. When I square -1, this undoes each other and we get right back to what's inside. So that I squared is -1. So this is something you have to know. So I hesitate to use the word memorize, but if that helps you, then go for it. All right, so this is I squared. We don't see I cubed very much, but just for funsies, we will show it as I squared times I. So this is -1I, which is just -I. All right, and then I to the 4th, then it goes back, would be I squared times I squared. Well, I squared is -1. -1 times -1 is +1. So I to the 4th is +1. I cubed is -I. I squared is -1, and then I is the square root of -1. So these two are the biggies, I and I squared, but sometimes I've seen a lot of this on ACT, SAT tests where you have to convert. Okay, so we're going to use I to simplify each square root. So similar to when we had to rewrite it, we're going to take out the 9, and then we're going to take out that -1. So the square root of 9 is 3, and the square root of -1 is I. When you make your I, kind of make them curly with that dot above it. Don't make it like a stick, then it'll start to look like number 1. All right. I don't know why that's hanging around, but it is. I can't get rid of that. I don't know why. All right, so then this one would be 5 times -1, which is 5I. We're not doing plus or minus yet because it's not an equation, but we'll get there. Right now we're still simplifying. That's the distinction. Okay, this next one, go ahead and take that out. Take out the perfect square factors of 72. Just going to get another color. Out. All right. 9 times 8, not big enough. Not big enough. You want to think big. Think bigger. 72 and 1. 72 is not a perfect square. So 1, 4, 9, 16, 25, 36. 36. Ding, 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 ding. Oh, shoot. Can't see that anymore. So this is the square root of 36, the square root of 2, and the square root of -1. So remember, just like I do it for the variables, I usually X that out, perfect, X that out, perfect, and then I'm left with root 2. So that is how you have to write it. You would not write it as 6 root 2I. All right, it starts to look, because this is all the coefficient. So that has to be in there. You would not do 6 root 2i. No. Yeah?
Where do you get the negative I from next to the 2?
The negative, it's the square root of negative 1. That was the very first lesson up here.
Where do you get negative 1 from? Because 36 is 2.
36 times 2 is positive 72. Positive times a negative is negative 72. 72 is negative.
Why is it 36 times negative 2?
Because we don't have the capability of taking the square root of negative 2, so I have to take out the negative 1. So that's always going to represent I. Alrighty. Alright, so I already talked about I squared being negative 1, so let's just rewrite that. Okay. Find the difference of each complex number. So officially, a complex number is real plus or minus imaginary. So an imaginary number on its own is that I business, but when I add or subtract with a real, then we call that complex. In real life, complex means like, oh, it's really tough, but it's really not tough. It's just called that mathematically. All right, so when you're looking for the difference or the sum, that's what this should say. Find the sum or difference, in case you're confused about that little typo. So just like if these were variables, you can only combine real. Okay, 4 plus negative 11 is negative 7. And then the imaginary, let's circle. Minus 7i plus 9i is plus 2i. Alrighty. So I can combine real and imaginary. But this is minus, this was plus. So let's distribute this first. Minus 2, a negative times a negative is a positive, and then 6 plus 8i just kind of comes down. So 6 minus 2 is the real part. Real means I can actually see it on the number line. Imaginary is like it bounces above or below it. Real is on the number line, imaginary is off the number line. But it counts as a, I hope that kind of, in the most basic of terms. Real is on the number line, bless you. Imaginary is a 0 above or below. All right, so 6 minus 2 is positive 4. And then let me circle positive 8i plus 5i is 13i. Now, the real has to come first, and then plus or minus the imaginary. So on the quadratic formula that I keep talking about, and any solution, you want to put real plus imaginary. Real plus imaginary. Okay, letter C. This is addition, so I'm just going to kind of combine. Negative 4, negative 2 is negative 6. And then 6i minus 9i is minus 3i. These are not like terms. Sometimes kiddos want to give me 9 or 3i or something. No, you're done. So real and imaginary are unlike terms. I mean, they're not even terms, really, so I'm going to use quotes, but they're not alike, so you cannot combine them. Do not combine. All right, so this is another subtraction, so we have to distribute. So 3 minus 2i, a negative times a negative is a plus 4 minus I. And then it just goes along. 3 plus 4 is 7. And then minus 2i minus I. If you're not in the habit of circling or underlining, that's fine. But I think it kind of helps. All right. I probably should have let you do one, but I didn't. Okay. Example C. Write the product in the form of a plus bi. Now, when we say a plus bi, it's sort of implied or minus. So hopefully that makes sense. All right. So again, make sure you can kind of see that I when I handwrite them, try to make them curly, but otherwise they're going to start to look like ones. So be really careful. So now product means multiply. Okay. So I'm going to do, here, I'll make this a little bit bigger. Negative 2.5i times 8 is, now here's where you probably might want to have your calculator. Obviously, I'm doing it in my head, but I want you guys to, I want to show you what that looks like. So you're basically just multiplying the coefficient, right? So I'll tell you how I do it in my head, right? You're taking 2.5 times 8. Twice 8 is 16, and another half of that is to add 4. Oh, calculator, this. What's that?
I got it.
Oh, gotcha. I was focused on
Your
my
calculator
feet.
is right here. Miss Buck, your calculator is right there.
Where is it? Oh my gosh. I'm losing it. All right. That's a great song, isn't it? Bumping in the club too. I'm losing it. You guys don't know what I'm talking about? Little Paris Hilton jam. We should play it. You want me to play it? Okay. What's that? Your cousin from Paris, so you're well aware that she DJs on the side, right?
No, she doesn't need it actually. She hired me.
Now he's just mad that she didn't pass me any of her
No. Nope, that's not it.
Can we throw a function in this classroom? Send us one. I don't come around.
Oh yeah, that's it. It's just, I don't know if these guys can hear it. They eventually start words. That's all the words are. Yep. That's it. That's all they say. So it helps. But now they're not saying it right now. Yep, you're not going to hear it. But eventually they do say those words, and only those words. All right. So any old who. Back to our math world. So negative 2.5 times 8 is negative 20. So that's what I was kind of doing in my noodle. I have to darken this so people can see it on the screen, on the big screen. Oh, sometimes this helps too. I didn't have the light on. This is, you see what I'm doing? I'm making my screen darker or lighter. You can just hit second arrow up or second arrow down. Okay, so this is negative 20i. Now, a negative times a negative is a positive. And then I'm just going to hit negative 2.5 times negative 9 to get 22.5. So if you put it in correctly in your calculator, it'll give it back correctly. But sometimes we don't use our calculator for good. So plus 22.5i squared. So you know enough by now. Can I leave this? No. What does this represent? Negative 1. So I have to multiply negative 1 to 22.5. So my final answer, because I have to do real plus imaginary, so let me put this in green. This is only part way done. Then I have to put the real first. It has to be real. That's why this is asking for plus imaginary.
So 22.5, negative 22.5.
Yes. Minus 20i.
Do you plus minus or no?
No, because it's only minus. These are both minus. I was saying plus, like, 'cause sometimes kids are like, I thought it had to be plus. And it could be plus or it could be minus. Not both at the same time. Okay, so let's do B. So this is a FOIL, right? We know how to do this. 3 times 3 is 9. First, outside, so that's 6i. Inside, that's minus 6i. Last, so that's minus 4i squared. Okay, we have to do, oopsies, that's off the grid. So this plus 6i minus 6i are like terms, but one is positive, one is negative, so that goes away. 9 comes down, minus 4 times negative 1. Well, that's just positive 4, and that is 13. So that's your final. All the imaginaries got the boot. All right.
Why did you go I? Oh my god.
They all got the boot.
For negative 20, it's I still.
Correct. It did not get the boot
And then cancel out.
because sometimes things happen and sometimes they don't. It's all very sad. So this one was a plus, one was a minus. If I made both plus, then it wouldn't go away. All right. Can we do one just like that for funsies for you? So here's 3 plus 2i, and here's 3 plus 2i. All right. So first, outside, inside, last. Oops, I keep going off the grid. I made this up. I just put this on the back of your packet if you want. All right, you with me, Kareem? So that is going to be 9 plus 12i plus 4 times negative 1. So this comes out to be negative 4. So 9 minus 4 is 5 plus 12i. So this one had it. This one didn't. So this is called the sum of, like here, this is what I did here. But here, this is a difference of 2 squares. All right. Oh, fractions. Don't we skip all those?
Wait, we don't.
Of course not. All right, so let's go. I'm feeling pink now again. 2/5 I times 10. So let me show you how to plug that in case you've forgotten all of 5th grade. All right, if you're using that alpha key, alpha F1, there's your fraction. So hit N over D, numerator or denominator, 2/5. Then you have to kick it out. Kick it out. Okay, times 10. Okay, so the thing you have to remember about that is it's 4i. There's a little I in there. Minus, I'm just going to do this one by hand because I think it's more of a pain to write it down. I know it's going to be negative, so I already took care of that. And here's our fractions. Remember, 2 times 5 is 10. 5 times 2 is 10. What's 10 divided by 10? 1. And then I squared. I times I is I squared. Oh, alpha. So if you were to do that on your calculator, let me just make this a little bit bigger. You're going to hit this alpha key. Alpha is the green key right here. Alpha F1 is above y equals. All right, so if I choose that, I have 2 over 5. And then I have to do it again, times alpha F1, 5 over 2, kick it out. Yay. All right, you want me to do the first one just by hand in case you're like, oh, that is actually easier. That would be 2/5, I, times 10. So remember, put the 10 over 1. So 2 times 10 is 20. 5 times 1 is 5. And then that's 4i. Alrighty. Now this, I usually circle the I squared. So I tell myself like, hey, Kath, it's -1. So a -1 times a -1 is a +1. But, can't leave it there. It's starting to look weird, right? Real plus imaginary. That one gets a heart. So fun. All right. This one, don't be silly. We can all do. What's a half times a half? What's half of 50 cents? 1/4. 1/4 minus, now I just want you to think of all these puffy cloud thoughts. Half of 2. What's half of 2, boys and girls? 1. So minus I, here's half of 2 again, plus 1i, and then minus, 2 times 2 is 4. I times I is I squared. All right. You with me so far? I foiled that puppy out. So 1/4 is just going to stay along for the ride. -1 plus 1 is going to go away.
Yes.
I owe you $10. I just paid you back. Okay? I had $10 and I spent it. All right, minus, there's that -1 again. So -4 times -1 is +4. So I wouldn't mind 4 1/4, but what a lot of you guys will probably do is do it on here. So if you did an alpha F1 and did 1/4 plus, what is it again, 4? 4, it would give you that as a fraction. If you did 1/4 plus 4, then it would give you as a decimal. If you do it all at once, then it's going to give you, it is going to give you that. What would it do if you didn't? If you did it backwards. If you did 4 plus 1/4, then it's going to give you, no, it's not. Okay. Well, usually it gives you garbage back. But anyways, so this one I would take 4 1/4, I would take 4 1/4, or I would take 17/4. They're all equivalent. So really, I don't love that question because to me, it's more important that you understand the I's, not that you can be tortured with fractions, but it is what it is. Can I flip?
Yeah.
Let's go. Okay. All right. Ooh, now we're getting into some fun. Now we're going to solve using the square root property. So we did this last chapter, but now I bet they're going to be imaginary answers. So I have to kick that over the fence. Then, what's the inverse operation of x squared? Square root of x. Boop. And then, now we've done this a couple times. But here comes my plus minus. Why plus minus? Equation. Equations get the plus minus treatment. A lot of you guys missed that on the test. It was, I remember it because when you grade 100 of them, that's what happens. This was the question. So you had to divide through, and then you got 49. And then what's the answer? Plus minus 7. So many of you guys put 7. All right.
Whoa, how did we get all the way down there? Yeah.
Well, you got to pay attention. What you been doing?
I was ready to do plus minus 2.
I said on the test, a lot of you, this was the test question.
Oh,
Do you recall?
I think so, yeah.
All right, but a lot of you guys just put x equals 7, and that was half off. Because you're literally missing half of the answers. So you got it. Same thing here. You have to do plus minus when you get to this. All right, what's the square root of 4? 2. What's the square root of negative 1? I. All right. So I kicked this over the fence. Last chapter, it would have made it positive over here. This chapter, we're just getting spicy. So I still have to, I'll scoot that. So to undo a squared, I take the square root. So x equals, right away, do plus minus. And then, can I just go right to 7i? All right. Because you're thinking 49 times negative 1. Okay, so let me do this one. 9x squared, I kick that over, negative 25. So this is why we had to do a little bit of fraction work, because kids always mess up their fractions. But these are both perfect squares, so it's really not bad. I'm going to take the square root. Maybe right away I'll just get kooky. X equals. And then the square root of 25 is 5. The square root of 9 is 3. And then I. So that is 25 ninths. If you want to like rewrite each one individually, you can. And then times negative 1. That's what you're thinking about. All right. The quadratic equation x squared plus 9 equals 0 has solutions x equals 3i and x equals negative 3i. How many times will the graph cross the x-axis? Never. Explain. So first off, let's sketch it really quick. So that vertex is 0, 9. So right away, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So it never crosses the axis. So remember I was telling you about these imaginary roots? Like they're imaginary. They cross above or below this axis. All right? So if it crosses the axis, then that's considered real. But anything above is considered imaginary. All right? So your explanation can be the graph never crosses the x-axis. Well, I guess I really shouldn't answer that because the zeros, the roots, whatever you want to call them, are above. And some of you might have said that these are imaginary. Plus or minus 3i are imaginary. So something about that. I might just Google that definition before we go today. All right, last one. The total source voltage in the circuit is 6 minus 3i volts. That's what that stands for. What is the voltage at the middle source? I don't think this is worth our extra today, so I'll just kind of skip that one because I do want to show you. Let's go to the internet for a minute, and I'll just show you some real life. And then homework is Delta Math just before I sign off. So that'll be on there, 5.1. Okay, so I'm going to stop here for a sec. For my absent people, kind of a bummer that today was that field trip.